Now it's perfect. Yeah. So, as I said, today is day 3, and as per the schedule, I'm going to discuss today the chi-square test, right? So, as a notion, as I was firstly discussing, since last two days, I was discussing the conceptual aspect of each and every test, and then we are proceeding for the hands-on practice through the SPSS. So, the same today I'll do. We are starting with the conceptual aspect of chi-square test, and then we will see how we can perform it using the SPSS, right? Just a minute. So now I'm sharing my screen. I want a confirmation from your side once you are able to see my screen. I think I shared my screen. I hope it is visible.
Yes, ma'am.
Yeah. So I'll start with the term non-parametric test. I think at the day 1, I have discussed there are two types of statistical tests in statistics. One is parametric and second one is non-parametric. So can anyone unmute him or herself and tell me what do you understand by term non-parametric test?
Yes, chi-square is a non-parametric test.
Okay, okay,
Yes.
fine. Anything else?
Chi-square test.
When the population is normally distributed, then we use parametric test.
Not getting. Will you please repeat?
When the population is normally distributed, then we use parametric test. And when we don't know the distribution of the population, then we have to use non-parametric test.
Okay, okay. May I know the name who was speaking?
Ranjit ma'am.
Ranjit. Okay, fine. So I think, as I said, or according to my opinion, if I say, parametric tests are generally concentrating or focusing on the normal distribution of the data. Usually, as I said at the day 1, for each and every statistical test, there are certain assumptions in statistics, right? So for the parametric test, one necessary or compulsory assumption is that your data should be normally distributed, right? But when we talk about non-parametric tests, here we are not bothering about the normal distribution of the data, right? So as again, I mean, want to say here one more thing. If we talk about the non-parametric test, and in case of parametric test, if your assumptions are not meeting, right? So in that case, also it is generally suggested rather than performing the parametric test, we can go for the non-parametric tests, right? So generally, non-parametric tests are the tests which are focusing on the categorical data. Categorical data means when the nature of your variables are nominal or ordinal. In that case, you can perform non-parametric test, because I think yesterday when we were discussing the normality and reliability, so in case of normality, I quoted, or I think I said this thing, that for the continuous or the numeric data, we are bothering about the normal distribution. If the data is nominal or ordinal in nature, in that case, we do not need to test its normality, right? So in that case, means when the variables are of the nature nominal and ordinal, we can perform the non-parametric test, right? So here you can read the points. I think point number 1 I have discussed. Second point says the sample sizes of the study groups are unequal. For chi-square, the groups may be the equal size or unequal sizes, whereas some parametric tests require groups of the equal or approximately equal size. So here, as I said, firstly, non-parametric tests are focusing on the categorical data. Second, non-parametric tests are not bothering about the normal distribution of the data. And as per the agenda, today we are going to discuss the chi-square test. So chi-square test is one of the non-parametric tests, right? So when we talk about a non-parametric test, that is chi-square test. So chi-square test means if we are talking about the two different variables, two different groups, and we are comparing the association, or we want to see whether these two are independent to each other or not. In that case, it is not mandatory that the size of those groups should be same, right? So that is the case of the chi-square test. In that case, you can even perform the chi-square test. Now, the second slide says I think in the first also we were talking about when you need to use the non-parametric test, and in the next also in continuation we are talking about the next point, which says the original data were measured at an interval or ratio level. Means whenever you are having the continuous data, that is numeric data, and your data is not meeting with the assumptions of parametric test, in that case you can perform non-parametric tests, right? Mainly the assumptions of the parametric test, as I said, generally it is talking about the normal distribution. And I think yesterday we have seen, to ascertain the normality of the data, generally one of the methods which we can use is the skewness and the kurtosis, right? So skewness and kurtosis value can help us to understand the normality of the data. And if your data is not following the parameters or the threshold values of the skewness and kurtosis, in that case you can jump from the parametric test to the non-parametric test. Apart from that, some more assumptions are there in case of parametric test, that is the homoscedasticity or the equal variances in the groups, right? And then generally we need to have the continuous data. These are some of the assumptions of the parametric test. So I think from tomorrow we are starting, so these things we will discuss tomorrow. But these are the assumptions which you need to check usually for performing the parametric test. And if these assumptions are not met by your data, in that case you can perform non-parametric test. So that means one requirement of the non-parametric test, the variable should be categorical in nature, and it is not necessary that your data follow the normal distribution. Second thing, if your data is of continuous nature, numeric nature, and still it is not meeting the criteria or the assumptions of parametric test, in that case also you can perform the non-parametric test, right? So non-parametric test generally talks or generally based on the median parameter of the measures of central tendency. But usually parametric tests are concerning about the mean and standard deviation or variance type of thing. Non-parametric tests can be based on the frequency and the median type of things. Then moving to the next slide. Talking about the chi-square test. Firstly, it is other way, or the other name of the chi-square test is the Pearson's chi-square test. It is given by the Pearson, and that is why after his name we can name this test as Pearson's chi-square test. So it is also a non-parametric test because it is distribution free. Distribution free means normal distribution free. It is not means it is not a requirement that you need to check the normal distribution of the data. Generally, it is known as the test of association between the variables. Means whether your variables are associated to each other or not, that you need to test using the chi-square test. Then it measures how expectations compare to the actual observed data. So I think we all understand, and I think we have seen the formula of the chi-square test. I think in upcoming slides also I'm going to show you. So you know this thing, generally the formula of the chi-square is based on the observed and the expected frequencies, right? So we want to check whether is there any significant difference in the expected and the observed frequencies or not. So that way we are performing chi-square test. Then it is used to measure the significance difference between the frequencies of the groups. So that way we will perform chi-square test in these situations. Now the important rule you can see to perform chi-square test, I already said that chi-square test only tests whether the two individual variables or two individual categorical variables are independent to each other or not. So binary format means yes and no type of or dichotomous scale type of variables, right? So in that case, we can say whenever we are talking about the categorical variables, we need to check whether these two variables are independent to each other or not. In such case, we can perform chi-square test on the variables. Then whenever we are interested or whenever we are having the frequencies with us, right? In that case also we should perform chi-square test. And you can see one precaution written here, that is chi-square requires researchers to use numerical values, also known as frequency counts, instead of using percentages. Means if you are having percentages, in that case it is not suggested to perform chi-square test. But if you are having the counts, if you are having the frequency values, in that case you can perform chi-square test. Till now it is fine. The pace is okay. May I proceed?
Yes, ma'am.
Yeah. Now further we are talking about types of chi-square test. So I think we all are aware that when we talk about chi-square test, we know that there are two types of chi-square test. The first one is the goodness of fit. Goodness of fit means where we want to see that observed frequencies are similar to the expected frequencies or not. In that case, we can say it is a goodness of fit kind of test. So here we will be having a single variable, and for that variable we will be having the frequency count. Say for example, I have shared a sheet with you. In that you can find, I have given both the sheets. One sheet I have given for the goodness of fit. Second sheet I have shared for the independence of attribute. So say for example, if I talk about the absenteeism in my class of the students, right? So on 7 days, I want to check how many absenteeism came. So for example, on Monday, I observed 7 students were absent. On Tuesday, I observed, suppose there are 2 students were absent, and likewise, I have calculated or count the absentees or absentee students in my class for all the 6 days in a week. And then I want to see this thing, whatever the observed frequencies I am looking over a particular week, whether these frequencies are equally distributed for all the 6 days or not. So that way you can see I am having only a single variable, that is the days, or that is a week, right? And in that week there are 6 days, so I can say that that particular variable there are 6 categories available: Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. And then if I am having such kind of variable, and along with that I am having the frequencies, so I can find whether the frequency distribution is equal throughout all the categories or not. In that case, it is known as goodness of fit test, right? Now talking about how to formulate the hypothesis for the chi-square goodness of fit. So with a very simple way of formulating the hypothesis is that generally we are writing there is no significant difference between the observed and the expected value, or observed and the expected frequencies. So this way we can formulate the null hypothesis, and alternatively we can say that there is a significant difference between the observed and the expected frequencies. I hope it is fine. Concept is clear of the goodness of it.
Yes, madam.
Fine, thank you. Moving ahead, you can see one more way of the formulation of the null hypothesis for the chi-square goodness of fit is frequency distribution is uniform across all the categories. Or you can write there is no significant difference between the observed and the expected frequencies. So this way you can formulate your null hypothesis for the chi-square goodness of fit. Here I have taken some examples. The first example says red, green, blue, and yellow candies are equal. Suppose you are having these 4 color candies available, and these are in different numbers, right? So you want to see whether that whatever frequency count you are having, that is same for all the colors or not. So you can go for the chi-square goodness of fit test. Then local car colors follow the global distribution or not. That way you can check. So whatever the local car colors you are having, that you can jot down, and that way you can see this thing whether that distribution is similar according to the global distribution or not. Now, equal number of customers visit shop each day. So these are the some of the examples. In such cases, we can perform chi-square goodness of fit test. So I am proceeding. If you are having any inquiries, if you want to ask me something, you can unmute yourself, or else I'm moving ahead. Now, talking about the second type of chi-square test. So here you can see the second type of chi-square test is known as the Pearson's chi-square test of association or independence of attributes. So this is the second type of chi-square test. Generally, this is known as the two-way chi-square test. Two-way chi-square test means here we will be having the 2 categorical variables. In case of goodness of fit, we have seen we will be having only a single variable, but in case of test of association, or in case of test of independence of attributes, you will be having the 2 categorical variable available with you. And in that case, you want to check whether these 2 categorical variables are independent to each other or not, right? So, example, you can see gender performance on driving test, whether that driving test score is independent of gender or not. So that way you can see driving test score maybe can be something, and then you can see gender-wise their distribution, and then you can find these two variables are independent to each other or not, right? So you can see how you can take that data. Gender, we know it can be measured in terms of male and female, and driving test results can become in terms of pass and fail. And that way you can make a proper table and you can calculate the frequencies. So hypothesis can be there. It is not no. There is no relationship between the categorical variables. And if you know that the value of one variable, it does not help you to predict the value of the another variable. Why I have written this line here? Because as you can understand, whenever we are talking about the association sounds like relationship, right? But association is generally we are looking for the categorical variables, right? And whenever we are having the numeric variable available with us, in that case we will go for the correlation, right? So there is no role in case of chi-square test, we are not interested to predict one of the categorical variables, right? So that way you can see whenever we are talking about the chi-square test, there is no rule or no role of prediction type of technique. Further, here I have taken one example from the question. You can understand. Suppose we want to measure whether there is an association between the ownership of car and the family type, right? So in that case, you can write your question whether ownership of car is related to family type, or you can write whether ownership of car is dependent on family type. So this way you can write your question of your research study, right? Now using these questions, you can make your hypothesis. There is no association between the ownership of car and the family type. And then you can write ownership of car is not related to family type. Then ownership of car is independent of family type. So can any one of you tell me here, I think we are having the two variables. Can anyone of you tell me which two variables we are having in these hypotheses?
Ownership of car and family type.
Very good. Very good. Thank you so much, ma'am. If you have correctly observed these two variables, so can you guess if you are having the data available with you, in which way you will collect the data for these two variables?
Ownership,
yes.
car and family type.
Okay. I hope, just a minute. Give me a second. I hope you would be able to understand what I'm saying. If not, give me a second. Word file is visible to you?
Yes, ma'am.
Yeah. I have written here ownership of car. This is your first variable. Size is, I think size I need to increase. Give me a second. Font size is okay?
Yes, ma'am.
Yeah. Now you can see, I think you people have correctly observed that the two variables are available in the hypothesis. One is ownership of car and second is the family type, right? So if I want to perform, as in the previous example, which I have just shown you in this slide, in that we were looking for the gender and the driving test result. Right? So where you have seen, for this we have taken the two categories as pass and fail, and in case of gender we can call it as male and female, right? So my question is very simple here. If I'm talking about ownership of car and if I'm talking about family type, so how I will measure these two variables? This was my question. So can
family type, you can measure with nuclear family, joint family, and other.
Very correct.
Thank you.
This is what I was looking for. Nuclear, joint, and in ownership of car?
First owner and second owner, ma'am.
Can I take it as yes or no?
Yes, ma'am.
If I belong to a joint family, whether I'm owning any car or not, if I belong to a joint family, whether I am owning a car, yes or no. Similarly, if I belong to a nuclear family, whether I am having a car, yes or no. So that way you can go ahead and that way you can see that if you want to check the independency of these two categorical variables, you can perform here the chi-square independence of attributes test. I hope now you people would be able to understand this thing.
Yes,
Is
ma'am.
it fine? May I proceed?
Please, ma'am.
Yeah. So further, the next slide says, if I talk about this chi-square chi-square independence of attribute test. So here you need to have firstly the nominal or ordinal variable, means your variable should be measured on nominal or ordinal scale, and that way you need to have their frequencies, right? So this way you can find the relationship, that is the association between the two categorical variables using the chi-square independence of attributes. Now, talking about the assumptions of Pearson chi-square test. So these assumptions, you can see these were given by these two gentlemen in the year 2000. And these assumptions says, the first one is individual observations should be independent of each other, right? So how to test the first assumption? First assumption is very simple. It says, again I'm repeating, individual observations should be independent of each other. That means if I will collect a data from one person only once, right? Say for example, I am the part of any survey. So if I am recording my responses only once, that way I would be able to make this first assumption. So that means this would be the precaution taken by the researcher. He or she needs to be very careful that he or she needs to collect the data from one person only once. So that way you can meet the first assumption of the chi-square test. Second assumption says expected cell frequencies should not be too small. That is, expected cell count should not be less than 5 in 20% cells. So at least in 20% cells, the expected frequency should not be less than 5. And if it is less than 5 in more than 20% cells, in that case, according to the thumb rule, you should not report the chi-square test, and instead of that, you should go for the Fisher's exact test, right? So these were the two important assumptions you need to test. First, we can check or meet according to our own data collection methods that you can do. And second, you need to check using the SPSS. SPSS will give you these percentages, and that way you can ascertain whether the assumption is met by your data or whether it is violated by your data, right? Further, talking about very important term of the chi-square test, which is the contingency table. Contingency table is a two-way table. Contingency table is a two-way table, right? So I think you all have seen, generally we are keeping one variable in in the row section, and second variable we are keeping in the column section. And in the combination of these, we are writing the frequencies. So this type of table is known as contingency table. So generally in case of independence of attributes, that is test of association, you need to make the contingency table. Although using Excel, we do not need to do anything. We can, or Excel, using SPSS, we do not need to do anything. SPSS will provide you this particular contingency table, right? But if you are doing your calculations in Excel or something, in that case, you need to prepare that table, right? So this particular table is nothing but this is the contingency table. So same example I have taken here. Family type is joint family or nuclear family member, and the car ownership is yes and no. So suppose a person belonging to the joint family and he is having a car, right? So in that case, the count is coming as 34. So you can find the next thing. Similarly, that if you belong to a joint family, if you are not having a car, so 66 type of people are like this. Nuclear family, yes, means car ownership, for that they are saying yes, there are 55 people are there. And similarly, for no and nuclear combination, you can find there are 45 people available. And that way you can say in yes category, total respondents are 89. In no category, total respondents are 111. Right? So this table is nothing but this table is known as the contingency table. This is a two-way table. One variable will be in the column, second variable will be in the row. Is it clear?
Yes, ma'am.
Yes, ma'am.
Yeah. Talking about the next slide, this slide is only indicating you the formula which we are using in case of chi-square test. Although we do not need to understand this thing, because generally today's era of software and using software, we can get easily these values. But still, for understanding the concept, as we are talking the terms observed and expected frequencies, so we can see the formula says chi-square. This is the symbol of chi. So this is chi-square equals to summation of O minus E square divided by E, or FO minus FE square divided by FE. So O or FO is what? It is your observed frequency, and E or FE is what? It is your expected frequency. So usually you need to calculate expected frequency if you are performing chi-square manually, right? Or using Excel also you need to calculate, using the Excel functions you can calculate that, or sorry, using the formula type of thing in Excel you can calculate them. So if I talk about goodness of fit, that is when we are having a single variable, single categorical variable. In that case, chi-square will be calculated as the first formula: total observations divided by number of observations. That means it is nothing but it is the mean of the observed frequencies. This is your expected frequency value. But in case of chi-square test of association or independence of attributes, E is what? It is the row total into column total divided by grand total, right? So again, I am repeating, we do not need to calculate manually, but we need to understand the concept, right? Moving ahead, this table is showing you the manual calculation of getting the value of chi-square, where you will be having the O. So you will take the mean value of this particular column, and that will become your second column. So the whatever mean will come, you will write in the second column. Then you will take the difference, you will do the square, and then you will divide that square by the expected count, respective value, right? And the sum of the last column will be nothing but this will be the chi-square value. And now I think, as today is the first day of understanding the statistical test, so as a notion I'm telling you what are the ways of interpreting your results. So if you are making your notes, you can write down, and if you are having already the knowledge, so there is no point of noting it down. So the first rule, for the manual calculation. So the manual calculation thumb rule says when your calculated value is less than your tabulated or critical value, right? Critical value, that is the table value. For each and every test, the standard table is available in statistics, right? So for chi-square also we are having the standard table available. So we can find its value from the table for a particular degrees of freedom, right? And that way you can compare these two values, and if your calculated value is less than your critical or tabulated value, in that case you are going to accept your null hypothesis. And opposite of this is if your calculated value is greater than your critical value, or your calculated value is greater than your tabulated value, in that case you are going to reject your null hypothesis, right? So this is the thumb rule of the manual calculation. But if I talk about the p-value rule, so p-value rule says that if p-value is less than level of significance, in that case we do not accept the null hypothesis, right? And if when p-value is greater than the level of significance, in that case we cannot reject the null hypothesis. So these are the two ways of ascertaining whether you are accepting or rejecting the null hypothesis. That will be based on the whether you are comparing your calculated and the critical value, or whether you are using your p-value and you are comparing this with the level of significance, right? I hope I'm okay till this point.
Yes, ma'am.
Are you people listening to me? I hope.
Yes, madam.
Yeah.
Yes.
Fine. Thank you. Going to the next slide, talking about the chi-square test, how you can perform chi-square test using the SPSS. So these are the ways which I have written here on this particular slide. But I'll repeat. I think I do not need to tell you that how you need to perform these, because I will tell you that using the SPSS. So Fisher's exact also I'll show you in the file only, right? So this example you can see, you need to write this particular example because same data I have given you in the sheet. So please read carefully this particular problem. Done? Reading done?
Yes, ma'am.
Okay, fine. So now I think I'm shifting to the chi-square, right? So I think I shared my screen. Is this visible?
No, ma'am.
No, ma'am. No, ma'am.
No,
Not
ma'am.
visible. Okay, just a minute. I think mistakenly, just a minute. Again, I'm sharing. Okay. Yeah, I think it is visible now.
Yes.
Yes, ma'am.
Yes, ma'am.
Yes. Fine. Thank you. Thank you, everyone. So now I'm expecting you to open the same sheet, which is with the name Candy Colors. And I think you need to firstly check in the variable view whether the 3 variables available with you or not. Available? Same sheet I think I shared. I think it is very similar, right? Any confirmation?
Session is opening, ma'am. It will take little time.
Yeah, it takes time. I know it takes time. First day, the same thing happened with me also. So that is why I beforehand open the sheets. Meanwhile, if you are having any queries regarding the chi-square, you people can ask me. I'm waiting. Once your sheet is open, please let me know so that we can proceed further.
Yes, it is open.
Okay, fine. Thank you. So if it is open, please cross check in the variable view or in the data view. Are you having the 3 columns, 3 variables?
Yes, it is there.
Yeah, fine. So now, friends, I am expecting you come to the variable view. And in the decimals, firstly, I'm making this 2 as 0. I'm converting these in the 0 using the up and down tree. So in both the in case of both the second, that is color, and the frequencies element, you can come and make it 0 for the decimals, right? And then I'm coming to the data view. So now you can see in the first column, I'm having the color, and in the further columns, I'm having the color and frequency. So can anyone tell me here, firstly, which type of chi-square test I need to perform here, and with which variable I need to perform that? I think case you all have read. What was the case? That condition problem you people have read, right? So understanding that and looking at the data, now you need to tell me which chi-square test I need to perform here, goodness of fit or test of association.
Goodness of fit,
Ma'am,
ma'am.
goodness of it.
Goodness of fit. Very correct. Very correct. It is a goodness of fit case because we are having a single variable available, that is color. Different categories available in the variable view. You can check it in the values. Once you will click, you can find 1 stands for blue, 2 for pink, 3 for green, 4 for brown, and 5 for yellow, right? So you can scroll down and you can see everything is available, 1, 2, 3, 4, and 5, right? Now, how to perform chi-square goodness of fit? For that, you need to go to the analyze menu. So I'm expecting you to go to the analyze. Click on the non-parametric tests and then click on the legacy dialogs. And from this, you need to select the chi-square. So this is the way to reaching the chi-square goodness of fit. I'm repeating: analyze step, non-parametric tests, legacy dialogues, and chi-square. I'm expecting you to note it down. If not, you can take the snap also of this particular
Okay, ma'am.
conversation. It is done?
Yes, ma'am.
Yes, ma'am.
Yeah. If it is done, you need to click on the chi-square. Once you will click on the chi-square, you would be able to see a dialog box for the chi-square test, right? Now you can find all the variables listed at the left hand side. We are interested in the first variable with the name color1. So you need to only shift this color1 in the test variable list like this. Apart from that, you can see in the second or in the lower section at the left hand side, expected range is written, right? So expected range is what? Expected range is saying get from data, or it is saying use specified range, right? So that means for calculating the expected frequency, if you are interested to give any range, means suppose I'm giving 15 to 20. So that means I'm giving a message to SPSS, my frequency count should be in between 15 to 20. Clear? So that way I can use the second option. Once I will click on that, you would be able to write the lower and the upper range. And that way SPSS, according to these two figures, will count the expected frequency for our data. Clear? But I think it is suggestive to go for the get from data. The second section at the lower section, that is situated at right hand side, says expected values. So here you can see by default all categories equal. So if you can recall, when I was discussing the conceptual aspect of the goodness of fit, and when I have shown you that formula slide, I said in case of goodness of fit, the expected frequency is what? It is nothing but it is the average of the observed frequencies, right? So that means throughout all the categories, you will write the same expected frequency. So that way, by default option is all categories equal. Second option is values. So once you are clicking on the values, you would be able to give the values also. Up to you what values you want to give. So that value you can enter, and then once you will enter any value, you can click on it. Presently, you can see add button is not active, but once you are typing something here, that button will be active. So that way you can shift that values, and these value will be stored as a expected values. So these are the two things you can do, but generally suggestive is in both the cases we should go for the by default option, right? So I think this is all you need to do, and then you can press on the OK to get the output. So I think I'm all set. May I click on OK?
Yes, ma'am.
Yeah. So once you are clicking on OK, in a few seconds you would be able to see its output. So in the output viewer, you can see the first table is saying these are the 5 candy colors listed there. These are the expected count, and then these are the expected frequencies available, right? Now you can come to the next section or next table, which is talking about the chi-square value. So before that, you need to read the assumption, which says 0 cells have expected frequencies less than, means in each and every cell expected count is greater than 5, and that you can check also. In each and every cell expected count is greater than 5. That means the violation is not there for the chi-square goodness of fit. So assumption is met by the data. Now we can come to the chi-square value, which is 2.5 for the 4 degrees of freedom, and its significant value is 0.645, which is greater than 0.05. That means we cannot reject the null hypothesis. We need to hold our null hypothesis, and that way you can say there is no significant difference in the expected and observed and the expected count of the candy colors, right? I hope it is clear.
Yes, ma'am.
Yes, ma'am.
So may I proceed for the next? I think voice is very lower. I cannot listen. I need to check my system. I think volume is full. I think I am clearly audible to everyone, right?
Ma'am,
Yes,
I
ma'am.
have a doubt.
Yes, please.
Ma'am, would you please go to the data view?
Okay, just a minute. I'm coming. Yes.
Ma'am, here how the observed frequencies of color 1 is converted into frequency table?
That is done by the SPSS, ma'am. SPSS has calculated how many times 1 is coming. 1 stands for here, I think, blue. So that way it has counted how many times 1 is coming. It's a software. It's programmed like this.
Okay, ma'am. Like when we entered column 1, it is all by default converted into frequency table.
Yes, yes. And that way you can
Okay,
see
ma'am.
one more thing I have taken here for now I was coming on that only. In the next 2 columns, you can see what I did. I have taken the data like 1, 2, 3, 4, 5. So here I have clearly mentioned 1, 2, 3, 4, and 5. And along with that, in the next column, I have written the frequencies, right? So that means I am having the same data. As you can see, just a minute, I'm coming in the output here. You can see here the observed values are what 25, 20, 20, 15, and 20. Now here you can see 25, 20, 20, 15, and 20. Same figures I have written here. I calculated that using the filter and something. I did that. So I want to tell you one thing here. If it means it is totally depending upon in which manner or which type of data you are having, or what is the presentation of data you are having. If data is presented like that, I think I have shown you how to perform chi-square goodness of it. Now you need to see if your data is in this particular form. In that case, how you will perform chi-square test, right? So now I think I am coming on that. Ma'am, I think your question is okay, answerable. I have
Yes.
answered that.
Yes,
Yes.
ma'am. Yes.
Yes. Coming to the next, now if you are having the data in this particular form, that means clearly your categories are mentioned. So you can use this, you can check. Once I have clicked on this label value icon, it is showing me. Once again I click on this, it is showing me 1 for blue, 2 for pink, 3 for green, 4 for brown, 5 for yellow, right? So that way you can see it is clearly showing me that these are the frequency counts written. Now, if you are having data in this particular form, how you can perform the chi-square goodness of it? For that, you need to again go to the analyze, go to the non-parametric tests, then go to the legacy dialogues and select chi-square. Same thing I have performed, but I think firstly I need to show you what the problem will be given by the SPSS if you are doing this, and then we will go to the correct way. I think, give me a second. There is a problem of battery, so I need to keep my laptop on the. Give me a second. I need to attach my laptop with the power. Yes, I'm back. Just a minute. Yeah. So I think we all have came here till this particular point, right? We all are on the same page. May I start explaining now?
Yes, ma'am.
You need to firstly reset whatever arrangement you have made previously. So I have clicked on the reset button. Now I'm shifting the color variable into the test variable box like this. And then I think previously also we haven't made any changes, only or except only shifting the variables here. So the same thing I performed here. I need to now only click on the OK button. So I think may I click on OK? It is fine.
Yes,
It is
ma'am.
okay?
Yes, ma'am.
So
Yes,
now you
please
can
go ahead.
sorry. So now you can see once I have done a click on my dialog box, you can see the output is coming very differently. In the previous section, you can find output was like this. The chi-square value was coming like 2.5, but here the chi-square value is coming as 0.000. So meaning is that here we have shifted our variable in the dialog box, but the problem is frequencies were not associated with the categories, right? So that means this is not the correct way of performing chi-square if the data is in this particular form. For that, what you need to do, I think this time I need to check. So now what you need to do, you need to go to the data menu. Data tab you need to click now. You need to go to the last option, weight cases. Everyone located it? May I click on this?
Yes, ma'am.
Yeah. So once you are clicking on this, you would be able to see, right, that it is showing you the wait cases dialog box, right? Now what you need to see, you can see by default it is showing you do not wait cases, right? So you need to click on wait cases by. Once you are clicking on this, you need to shift your frequencies into the frequency variable box. Done?
Yes, ma'am.
And then you can
Yes,
click on
ma'am.
the OK. Yeah. If it is done, you can click on the OK. Once you will click on the OK, you would be able to see at the bottom right, you would be able to see one status is coming as wait on, right? Is it fine?
Yeah.
May I proceed?
Yes, ma'am.
Yes, ma'am.
Yeah. Now, again, you need to go to the analyze, then non-parametric test, legacy dialogues, and the chi-square. And then, if you want, you can reset it. Again, you can shift your color variable into the test variable list, and then you can press on OK button to get the output. Once you are pressing on OK, I think we are getting the results, right? Yeah. You can see now it is showing you correctly. Fine?
Okay.
Yes. Fine. So now you need to interpret your results. So you can see that output is very similar what we got previously. So that way the similar interpretation we can draw from this output. So this way, this is known as chi-square goodness of fit. I think both the ways or both the form of data I have shown you, and we have performed chi-square goodness of fit. Now we will move for the next category, that is chi-square independence of attributes or test of association, right? So for that, I think I forgot to open the sheet. You need to open the sheet I have given to you, that is education dog honor. This is the sheet. Open?
Yes, ma'am.
Yeah. So now, as you can see, there are few variables listed here: ID, gender, pet owner, education, right? So what I'm doing, I'm using here the two variables, gender and pet ownership. And using that, I will try to test the test of association between these two categorical variables. If I'm having gender and pet ownership as two categorical variables, you can come and see in the variable view. I think everything is clearly defined here. You can find in the value labels, one for male, two for female, right? Similarly, pet ownership, you can click on this. 0 says no pet, 1 says owns pet, right? Then education is 1, 2, and 3, 1 for high school, for postgraduate. So as I am taking only the first two, gender and pet ownership, can anyone help me that how I can formulate my hypothesis for gender and pet ownership if I want to perform chi-square test of association? Any suggestions?
Ma'am, will it be like there is no association between gender of a person and his or her pet ownership?
That can be a one way, correct? This can be a one way. Can anyone tell me some other way of formulating this hypothesis? This is correctly you said, ma'am.
Male have either they have no pet.
Yes. Please try to say something. Try to attempt. Attempt is very important. I think we all are at the learning phase. So if you will attempt, sir, it will be good. Yes.
Ma'am, another one can be like gender of a person does not have a significant impact on his or her pet ownership.
This can be one more way. Very good. If I want to use one more term, that is independent, can I use? Can I say
Yes,
pet
ma'am.
ownership is independent of gender?
Yes, ma'am. Yes.
Yes. So that way means ma'am has told us 2 ways. I think I tried to give you one more way. So that way we people are having total 3 ways of formulating the null hypothesis and alternative hypothesis for chi-square chi-square independence of attributes. So here I am taking that pet ownership is independent of gender, and I think we have already seen that 2 categories are available in this very categorical variable, and 2 categories are available in the pet ownership variable. Now to perform chi-square independence of attributes, you need to go to the analyze tab. Then you need to go to the descriptive statistics, and then you need to select cross tabs. Again, I'm repeating: analyze, descriptive statistics, and cross tabs. Fine?
Yes, ma'am.
Yes, ma'am. Yeah. Thank you, everyone. You can click on this. Once you are clicking on this, you would be landed on the cross tabs dialog box. Here, you need to shift one variable into the rows or into the row dialog box, and second you need to shift into the column box. So there is no thumb rule or no particular rule that which variable need to shift where, right? So generally, one variable means, suppose I am taking gender on my row and pet owner in my column. In my table, in the columns there will be the pet ownership, and in the row there will be the gender. That means male and female, yes and no would be there. Something this type of table you would be able to see. And after that, you need to click on the statistics button. Once you are clicking on that, you need to click on the chi-square. Then you can click on continue. Then you need to go to the cells button, and here in the first section, that is counts, you can find observed is by default selected, but we need to test the assumption of chi-square using the expected count. So that is why I'm selecting the second option, expected. This is all you need to do, and you can click on the continue button. And I think we are all set to generate the output now. So now I'm clicking on OK. So I hope till now it is everyone is with me. It is fine. May I click on OK?
Yes,
Yes.
ma'am.
Ma'am, just a second. Would you please stop your screen at what you performed at statistical and cell, so that we can take a screenshot? My SPSS is not working.
Oh, I need to close this. This is what you are saying, or I need to repeat again?
Ma'am, repeat and hold the screen for a second.
Yeah, miss, this is what
At
you want to see?
statistics.
I need to click on this? Okay, fine, I did.
Yes, ma'am.
Fine.
And next, cell.
Next is cells. So you would be able to see here, ma'am, in the the heading of the dialog box will be the same, cross tabs, cell display. So it is showing you.
It is done, ma'am.
Then you have
Done,
selected.
ma'am.
Yes.
Thank you so much.
Fine. Thank you. So now clicking on the OK to get the output. So I'm clicking on the OK button. So you would be able to see now output is available in the output where the first table is talking about case processing summary. So here you can find we have performed the cross tab in the on the 2 variables gender and pet owner, where you can find there are total 20 observations available. There were no missing values, so total count is 20. Coming to the next table, which will help us to understand what is the count and expected count. So here you can see in the row we have taken the gender variable. So in the gender we will be having 2 categories, male and female. So for male, count means this is the observed frequency, and this is the expected frequency or expected count. Similarly for female, observed and expected count. Pet ownership, no pet and owns pet. So that way this is the contingency table we have received from the SPSS. So now you can see expected count is calculated. Usually we know, as I have shown you, formula is row total into the column total divided by grand total. That way this is calculated by the SPSS, right? Now you need to stop it. I need to shift it here. Yeah. Now you need to see the chi-square test table, but firstly, before interpreting this table, you need to see whether your data is meeting the assumptions or not. So that way you can see the A point is written, which says 2 cells have expected count less than 5. And total how many cells we are having? 4, right? One male and no pet combination, 1 cell, male and owns pet combination, 2 cell, female no pet, 3, female owns pet, 4. So that way 4 cells we are having, and out of these 4 cells, in the 2 cells, that is this. Here you can find the expected count is less than 5, and this is expected count is less than 5, right? So that means 50% of cells are having expected count less than 5. And if you can recall the slide I have shown you, that 20% till 20% it is permissible, but more than 20% it is not permissible. That means assumption is violated by the data. Clear?
Yes, ma'am.
Yes, ma'am.
Yeah. So now you can see, if you can again recall, I said if your assumptions, if the assumption of chi-square is not met by your data, in that case you should not report the chi-square figure or chi-square results, and that way you need to go for the Fisher's exact test. So you can find this particular table is containing the Fisher's exact test, right? This test value is coming as 0.350. This is the p value. So it is greater than 0.05, right? So that means you cannot reject your null hypothesis, and null hypothesis says that pet ownership is independent of gender. That means there is nothing to do with the gender of the with the pet ownership. Means whether it is a male or female, they can own the pet, right? So this way, this is the conclusion of this particular chi-square test table. Now, friends, I am expecting you. I think we are having one more variable available with the name education. So now, can any one of you perform chi-square test using the pet ownership and education? I'm stop sharing my screen, and I'm expecting, can anyone share your screen and show how we can do that? It would be a great thing if you can do that. I'll guide if you are having any problem. Anyone?
I have a question.
Yes.
I have a question. Can we do this with 3 variables instead of 2? For example, if we add a type of pets one can have.
No, sir. That is the limitation. Only 2 variable is permissible.
So what would be the alternative then?
In that case, sir, we are having some other. We are having 3 categorical variables.
For example, one was pet owner and the other one was gender, and third one could be the type of pet.
Will you please repeat?
We have one variable as pet ownership, and the number is the gender. And if there is another variable which could be the type of pet, whether it is a cat or a dog or it is a hamster.
Okay. So
In
you
that
want
case,
to.
in that case, which alternative formulation can be attempted? Which alternative test can be attempted?
And sir, what do you want to see? Anything like here you want to see the independency. So if you
Dependency or independency? Either way.
So, sorry?
Either way, it could be dependency of all the 3 variables or
So if
independent.
there is one more test, I think with the name McNamer. You can find it is available. I think in SPSS also it is available. McNamer.
Okay.
McNamer, I think this is the test available. Using that, we can compare more than 2 categorical variables.
Okay. Thank you.
Okay. So anyone who is going to, okay, Indrajit sir is presenting the screen. Very good. Thank you so much, sir.
Thank you, ma'am.
Okay.
This is the output, ma'am.
I think, sir, we are not able to see your output. I think I cannot see. Anyone can see the output?
No, ma'am.
Okay. Indrajit sir, have you shared your entire screen?
Yes, ma'am.
But I think it was not visible to us. Is it possible for you to share again?
Yes, sir.
Okay.
It is visible, ma'am.
Yeah, visible. Give me a second. I think I need to see. Yeah, I am increasing the size. Now it is visible to me. Correct. Yeah, I can see now. So, yeah. Sir, can you interpret the results, or any of you can interpret the results?
Male have high school one.
Yes, sir.
Whereas female has high school qualified 4, who has first high school 4, compared to whereas male graduate is 8 and female graduate is 4, and male postgraduate is 1, whereas compared to female postgraduate is 2. Okay, got postgraduate degree. And ma'am, from the chi-square table, it's found that there is 20 data set, 20 case number of data set, and no missing value is there.
Correct.
And
then
yes, degree of freedom is 2, 2, 2, and 1. So
correct. Further,
it is 2 tail and p value is 1.77. First p value is
I think it is 1.77. It is 0.177.
It's 0.177, which is more than 0.05. That means null hypothesis is failed to accept.
Sir, can you
When is it accepted?
sir, please wait. Can you tell me your data is meeting the assumption or not? First, you need to test that. You need to check that firstly.
Okay.
Ma'am, here the expected count of 66.7% cells is less than 5.
Yes. So that means assumption is not meeting in the real, sir.
Yes, ma'am.
So I think, as I said, if your data is not meeting the assumption, you need to perform exact test, Fisher's exact test. So I think your table, your output is not showing that, right?
Yes, ma'am.
So the reason is that why I ask you people to perform, because this is a rule when you are having 2 by 2 table. 2 by 2 table means when you are having 2 categories in the row and 2 categories of the column variable. In that case, your SPSS is giving you the Fisher's exact test by default. But when these combination changes, so here you can see, I think you are having 3 level in the education. So your table is now 2 by 3 or 3 by 2, right?
Yes, ma'am.
So that way, if this is the case, in that case, SPSS will not generate the output for the Fisher's exact test. And that way you need to do one more thing. So sir, can you perform chi-square test again?
Yes, ma'am.
So sir, you need to go there.
Analyze, descriptive, cross tab, and
now, sir, now you need to
reset.
click on the first button. Like everything, okay, doing reset, okay. Perform.
Okay. Education and exact expected. This is the first bottom.
Now in exact, you need to select the second option, exact.
Exact. Okay.
Yes.
And statistics, chi-square, cell count, expected. Right, ma'am.
Yes,
now
correct.
I'm go. Okay.
Yeah, fine.
This is the result output.
Now you can get the Fisher's exact test, I think. Now, are you getting?
Yes, ma'am. Yes, ma'am.
So that way you can now see what is the level of significance. Although I think according to chi-square and according to Fisher's, in both the cases, you can see, I think your null hypothesis is accepted, right?
Yes.
Yes. So you can report chi-square and then you can strengthen your results by reporting Fisher's also. That you can write that chi-square test assumptions are not met by the data, but still the results of Fisher's and chi-square both are similar. Both are not rejecting the null hypothesis. So that way you can report Fisher's also. Is it okay?
Yes, ma'am.
Yeah. So I hope the chi-square, goodness of fit, and independence of attributes both are clear to everyone.
Yes, ma'am.
Okay. Indranil sir is saying yes. What about the others? Everyone is okay with this? Yes.
Yes, ma'am.
Fine. Thank you. So I think this is all from my side for the day. Now platform is open for question and answer. If you want to ask me anything related to chi-square test, which whatever we have discussed today, we can, or you can ask me. Okay, no queries. No questions.
Ma'am, why we do not perform goodness of fit through analyze, descriptive, and cross-step?
Because sir, it is requiring the two variables you need to shift. I haven't tried that. I think we can try. I think I haven't this time. Give me a second. As you have asked me, I'll try that. I haven't performed previously, but this is a good question. I'll try that. Give me a second, sir. I'm generating the results. If it is coming, so it is fine. Yeah, I did that, sir, but it is looking for the second variable also to shift in the columns. Even you can try. Please share your screen if it is possible, sir, or if not, I'll share, as you say. I need to share my screen.
Yes, ma'am.
Give me a second. Yeah. I have shared. I hope it is visible, right?
Ma'am.
Now you can see I'm going to the analyze, going for descriptives, and now selecting the cross steps, right? Now shifting the color variable into the rows. And as you can see, we are not having the second variable, so I cannot shift in the columns. Now clicking on the statistics, selecting the chi-square, clicking on continue, going to the cells, clicking on expected, and clicking on continue. You can see this is all we need to perform chi-square, but after doing every arrangement, you can see this OK button is not active here.
Yes, ma'am. Because we are putting only one variable.
Yeah, and
for
cross
goodness
step
of fit,
means
yeah.
from name itself, it is very clear. It is cross step. It is cross tabulating your two variables.
Okay, ma'am. Thank you very much.
Yeah. But I think it's good you asked. Even I haven't explored previously, but it's good. Okay. So any other queries? I think this way it is good to understand also. Thank you, Indranil sir, for this.
Thank you, ma'am. Thank you very much.
Yes. Any other queries? Okay. Vivek sir, do you want to ask me something, sir?
Ma'am, my question is very simple, that a person who has not background from the mathematical or statistical, so what is the source so that they can get the aware about the test and how they are implement?
Sir, I think practice is the only solution in that case. Even it is like I have done my BSc in mathematics also, but I haven't studied statistics till my graduation. I have only studied statistics in my MBA. That is only for the 3 to 4 months. But as I belong to the mathematics background, it produced, or what I can say, I tempted towards statistics. So I explored and I have developed this. So if you want, because I think, are you an academician, sir, Vivek sir?
Yes, yes, ma'am.
So I think we know, being an academician, we need to write research papers, right? So there are two papers generally compulsory for each and every one of us to write in a year, right? So that way, I think we are not having, generally we are team up a paper. We are not writing a paper alone generally. And we are looking for a person who is good in this particular thing. We are generally approaching him or her, right? But many times it happens, we want, because statistics is like that, whenever you are presenting your paper in front of in any particular conferences or in front of any particular panel. So generally, they are more focusing on these things. And if you are
Absolutely
dealing
right.
with introduction and LR part, generally they are not talking out much about those things. So in that case, we are feeling like that they haven't asked anything to us. I think this happened with me also. So that is why I tried to develop it. So sir, my suggestion is, if you want to develop this thing and you are having the interest, because generally you need to this is what my observation is, you need to produce that interest. Without interest, I think you cannot learn. So firstly, try to read the books. I have studied SP Gupta. I think it's
Right.
the book is like this much.
Textbook.
The pages will be around 800, 900 something. But you need to see, because that book is very thorough book, right?
Great.
So I suggest you read book. Apart from that, there is one more book with the name Sondhi and Chawla. It is based on research methodology. This book is of research methodology. These books are of the Indian authors only. Usually people are saying you need to refer the foreign authors book. But I think being an Indian, I prefer to read firstly the Indian authors. And the language is very easier to understand. So I think if you are reading these books and if you're practicing, because these all things will come from practice, sir. Even in my
Right.
MBA, after MBA, when I was doing my job and I was pursuing my PhD, even then, in that case also these clarities were not in me. But I think with the time, I have grown these things. So I think you can also do that. You need to only understand the thing. Firstly, what are the parametric tests? What are the non-parametric tests? You need to understand what are the basic requirements of the things. Say, for example, if I'm asking you, if I'm having the weight of the students, right? And I want to see whether male and female weight is similar or not. Means whether there is any difference in the weight or not. So the problem is very clear. It is telling you need to compare the weight of male and female. So weight is a numeric variable. Male and female will be what? These will be the gender, right? So that means I can say I have one categorical variable with two categories. And if I am looking for difference, so in that case, in a statistics, two tests, or I can say three tests are available, which can help you out to find the difference. First is Z, then T, and then ANOVA. So if you are knowing what are the requirement of Z, T, and ANOVA, you would be able to find that this would be the appropriate test in this condition or on this data to perform, right? So I think this type of understanding you need to develop. Although I tried, I will try in this particular FDP to explain these things which we are going to discuss in this. So once if you are jotting down, because whatever I'm saying now, it is very important to written.
Yes, ma'am.
And then from practice, I think you can learn this. And then you can apply these things on your data. I think, Vivek sir, you are getting my point, right?
Yes, yes, yes. Absolutely right, ma'am. Thank you so
So,
much. Thanks a
yeah.
lot.
So thank you so much, sir. So I think this is what I'm explaining to my students also, because even they are saying the same thing to me, ma'am, how you can easily say that this test you can perform on this data. So I said this thing to them also. If you are understanding the concept, if you are knowing that T test is for the significant difference, Z test is for the significant difference, correlation is for the finding the relationship between the variables, and what are the nature of the variable is required for performing these tests. If these things you are knowing, in that case, I think nobody can stop you to perform statistical tests. And then softwares are available to perform these tests.
Right, ma'am. Thanks.
Good evening, ma'am. Good evening, ma'am.
Good evening, sir.
Ma'am, can you share your email or contact ID with us?
Okay. Okay, I'm dropping it in chat.
Yes, ma'am.
I'm dropping it in the chat box, sir.
Okay. Thank you, ma'am.
Yeah. I think it is available. I think one of the, you are asking about the WhatsApp link. So Yogra sir, if you can share the WhatsApp group link in the chat box. I think few participants also want to join the WhatsApp group. Yes.
Good evening, ma'am.
Yes, good evening.
Ma'am, as I have discussed the day before yesterday, that we people are not able to download their 64-bit version of SPSS software. Can you please provide us 32-bit of SPSS link so that we can able to download it nicely?
I think to do the Google, you need to Google this thing. I think it will be little hard now because with the time now, I think it is not possible to get the 32-bit SPSS.
Actually, we people are finding it on Google itself, but there are lots of links provided over there. Henceforth, I'm just confused from which link we have to download.
Okay, I'll try to find. If I'm getting, I'll share in the group, ma'am.
Definitely, ma'am. Thank you.
Thank you so much, ma'am.
Ma'am, for me also having the same issue, ma'am. Actually, I can't able to download that SPSS. I'm searching how to download.
It is similar problems at 32-bit and 64-bit.
Mine is advanced, ma'am, but it's not signing up. I tried some other way also, but I can't able to open the SPSS, ma'am.
Okay. Okay.
I recently purchased that is 64-bit system, but
Okay.
I also having the same problem. I can't able to go behind that sign up stage.
When you are having 64-bit, then why you are facing the problem, sir? Because of email ID?
No, ma'am. I already given email ID, password, everything is going. After sign up, it's not opening. And I changed.
So for the first time, you have downloaded it?
No, ma'am. I downloaded, and again I uninstalled. Again I downloaded, but I
So
can't.
when you have downloaded previously?
Yes, ma'am.
No, I'm asking when you have downloaded previously.
First day, ma'am.
On day 1.
Yes, ma'am. Yes, ma'am.
But I think in that case, so sir, that .exe version is available with you, no?
Yes, ma'am.
In your download, so you can take that from the one computer to the other computer, and that way you can download that. It will be no problem.
Okay, ma'am. Okay.
Because problem is that with the IBM SPSS, if you are using the same email ID twice, it will not allow you to download. It will not allow you to download.
Shall I change the mail ID?
You can try that. So you can try that. Sometime it happens on the same machine also. It is not allowing you. So if you are having a different laptop, so you can use your different email ID. In that case, you can download it.
Okay, ma'am. Okay, ma'am. I will check and I will find, ma'am.
Yes.
Thank you, ma'am. Thank you so much, ma'am.
Thank you so much, sir. So I think if no more questions, can I expect you people to switch on your camera so that I can capture you for the day? Okay, I can see Vivek sir. Okay, Nandin Kumar sir, Sonath sir, very good. Okay, Savita ma'am, Indranil sir, that's great to see.
Great to see you, ma'am.
I think I captured. Thank you so much, everyone.
Thank you.
Yeah, so I think if no more questions, thank you so much, sir. So if no more questions, can we wind up the meeting for the day?
Yes, ma'am.
Okay. So thank you, everyone. We will meet tomorrow, and probably I'm going to discuss key test tomorrow.
Thank you, ma'am.
Thank you, ma'am. Thank you, everyone. Yogaraj sir. Thank you, sir. Sir, Yogaraj sir, we are done. So can I leave the meeting? Yeah. Thank you, everyone. Thank you, sir. Thank you.